What are relative and absolute fossil dating methods? Imagine trying to figure out how old a mystery object is without a calendar. Sounds tricky, right? Well, scientists do this all the time when studying fossils from our ancient past. They use special techniques called relative and absolute dating to piece together the story of human evolution and the history of life on Earth. Relative dating is like lining up photos from different years without knowing the exact date. It helps scientists understand which fossils are older or younger compared to others. The main method here is stratigraphy. Think of the Earth's layers like a giant layered cake. Deeper layers are usually older because new layers pile on top. When archaeologists dig up a site, they find that fossils in the lower layers are older than those near the surface. This way, they can create a sequence from oldest to newest without knowing the exact years. Another relative method is biostratigraphy. It uses fossils of specific animals called index fossils. These animals lived during particular time periods. If a fossil is found alongside an index fossil, both must have existed at the same time. This helps scientists connect different sites and build a bigger picture of when things happened. Chemical analysis is also used for relative dating. Bones absorb chemicals like fluorine and uranium from the soil over time. The more of these chemicals in a bone, the longer it's been buried. While this doesn't give an exact age, it helps compare how old different bones are relative to each other. Magnetostratigraphy is another technique. Earth's magnetic field has flipped many times through history. Rocks record these magnetic changes. By studying the magnetic patterns in rocks, scientists can match layers from different sites and figure out their relative ages. Now, absolute dating is like having a clock that tells you the exact year. It measures specific properties of materials to give a calendar date. One common method is radiocarbon dating. It measures how much carbon-14, a radioactive form of carbon, remains in organic materials like bones or wood. When an organism dies, it stops taking in carbon-14, which then decays at a steady rate. By measuring the remaining carbon-14, scientists can estimate when the organism died, usually up to about 50,000 years ago. For older fossils, potassium-argon dating is used. It measures how much potassium-40 has turned into argon-40 in volcanic rocks. Because this process takes millions of years, it's perfect for dating very ancient fossils in Africa and other volcanic regions. A more refined version is argon-argon dating, which measures ratios of different argon isotopes in a single sample, giving more precise ages. Uranium series dating looks at uranium isotopes in bones, teeth, and shells. It can date materials from a few thousand to over 1,000,000 years old. This is especially helpful for dating early human fossils when other methods aren't suitable. Thermoluminescence and electron spin resonance are techniques that measure radiation damage in minerals and tooth enamel. When minerals are heated or exposed to natural radiation over time, they store energy. Releasing this energy as light or measuring the damage helps scientists determine how long ago the material was last heated or exposed. Dendrochronology, or tree ring dating, is another method. Each year, trees grow a new ring. The width of these rings reflects environmental conditions. Matching tree ring patterns in wooden artifacts to known chronologies can give exact calendar years. In paleoanthropology, scientists often combine these methods. Relative dating helps establish the sequence of fossils, while absolute dating provides the actual ages. Together, they help us understand when our ancestors lived and how they evolved over millions of years. By using these techniques, researchers can piece together the timeline of human history with remarkable accuracy.